This is Mrs. Juliana again. We are going to be doing 15.2, proofs involving parallel lines, as you see right here. And I'm very excited about that because this is our final section in the unit that we had started prior to this whole COVID-19 thing. All right, if you look at this packet, I'm going to zoom out here for a second, you notice that with this lesson you have 4 parallel proofs or theorems that you already know. Notice they all end in theorem. And then you have 4 converse theorems. All right, so the whole lesson today is going to deal with corresponding angle theorem, alternate interior angle theorem, alternate exterior angle theorem, and consecutive interior angle theorem. Those are the theorems that we're dealing with in the beginning. And then after we talk about those, we're going to deal with the corresponding angles converse theorem, alternate interior angles converse theorem, alternate exterior angles converse theorem, and consecutive interior angles converse theorem. So if you remember a while ago, we talked about hypothesis and conclusion and how they relate to a conditional. That means an if-then statement. So if it says if 2 lines are parallel, then the pair of corresponding angles are congruent. I wanted you to look at that, kind of zoom in a little bit more, and then look at the corresponding angles converse theorem. Notice it just switches that if-then statement, which is the hypothesis and the conclusion. Now it says if 2 lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. So notice that it's been switched. Remember I told you with the converse theorems, if you had a hypothesis that is, if it is a cow, that's a cow, then the conclusion is then it will moo. If it is a cow, then it will moo. That's the original hypothesis and conclusion, the original conditional. And then if you switch the two, if it is a cow, then it will moo, then that becomes the converse. So you can just switch the hypothesis and conclusion, and you have the 2 theorems that we're talking about. So what the converse does is we use these converse theorems when trying to prove that A is parallel to B, for instance, that line A and line B are parallel. If we don't know they're parallel, then we're going to use the converse theorem. If we don't know they're parallel and we find that these 2 angles are indeed congruent, then we conclude that A is parallel to B. If we know that the 2 lines are parallel, then we can use the corresponding angle theorem to prove or to say that corresponding angles are congruent. So here we're proving that corresponding angles are congruent given the lines are parallel. Here we're proving that the lines are parallel given or finding that the corresponding angles are congruent. And the same thing goes for the other theorems. The alternate interior angle theorem says that if 2 lines are indeed parallel, I'm going to draw the little arrows here, then alternate interior angles will be congruent. That's what alternate interior angle theorem says. The converse theorem says if 2 alternate interior angles are congruent, then the lines are parallel. Right? So again, if you're trying to prove lines are parallel, we use the alternate interior angles converse. If we're trying to prove alternate interior angle theorem, that the 2 lines are parallel already, and we're trying to prove that they're congruent, the 2 alternate interior angles are congruent, then we use the alternate interior angle theorem. Same thing goes with alternate exterior angle theorem. If we know 2 lines are parallel here, then we know for sure that angles are congruent. Alternate exterior angles converse theorem says if indeed these alternate interior angles are congruent, then the lines are parallel. And then the consecutive interior angle theorem says that if I have 2 angles whose sum is 90 degrees, let's see, if I have 2 lines that are parallel, all right, so we know for sure they're parallel, then the angle sum is 180 degrees. Have a good day today. All right, so consecutive interior angle theorem says if two lines are parallel, then our consecutive angles sum to 180 degrees, whereas the consecutive interior angles converse theorem says that if I have two angles sum to 180 degrees, then the lines are parallel. All right, so they're just the same theorems we know. We're going to use them in proofs, of course. Lucky you. I need to watch my time because I have to keep this fairly short. I'm going to do the first two proofs with you. And then after we do that, I'll probably do, well, maybe I'll do one proof and then I'll stop the video and do a few more. How's that? And that will make it so that it will upload properly. Figured out lately. All right, here we have that C, D, and AB are parallel. Now, my suggestion to you is when you see this statement that they're parallel, that you draw a line with an arrow. So you know those are the parallel lines because sometimes there are several lines and it's hard to tell the difference between those that are parallel and those that are not. So when I have those two parallel lines, and then I'm also given that 2 and 1 are congruent. All right, so I like to mark those to show that indeed they're congruent. So what we're trying to prove is that 2 and 3 are congruent. We're trying to say, hey, are these two congruent also? So the first thing we're going to do is we're going to state that our CD is parallel to AB. All right, with that given, we can actually state that because of that, angles 1 and 3 are congruent because they're parallel lines, right? And that we can do by the alternate interior angle theorem. If two lines are parallel, then their alternate interior angles are congruent. So number one is given that the two lines are parallel. So the second statement we're going to say is angle 1 is congruent to angle 3, and that's because they are alternate interior angles, and we have a theorem stating that they are therefore congruent because they're alternate interior. So you hopefully can see that on that transversal there. All right, now because we're also given that angle 2 is congruent to angle 1, that was the given, then we have a setup for the transitive property. If 2 and 3 are congruent both to the same angle 1, then 2 and 3 are congruent, which is what we're trying to prove. And that allowed us to take our information that we were given and prove that angle 2 is congruent to angle 3, and that's by transitive property. Remember, the transitive property says that if two angles are congruent to the same angle, then they are congruent. Right? Cool. Okay, I'm going to stop the video, upload it, and then come up with the second video. So stay tuned.